Hi guys, welcome to the Group 2 channel. Today we are gonna talk about elements, atoms, and their history.
The history of the atom. Democritus was a Greek philosopher who was the first person to use the term atom. This is Democritus. He called this the history of the universe. All matter consists of atoms, which are bits of matter too small to be seen. There is an empty space between atoms. Atoms are completely solid. Atoms have no internal structure. Each atom is a different in size, weight, and shape. John Dalton was the first to adopt Democritus' theory into the first modern atomic model. This is John Dalton. John Dalton's atomic model. Number 1. All matter consists of tiny particles called atoms. Number 2. Atoms are indestructible and unchangeable. Number 3. Elements are characterized by the weight of their atoms. Number 4. When elements react, it is their atoms that have combined to form new compounds.
So this is J.J. Thomson. J.J. Thomson was a physicist who is credited for discovering the electron. He used his research on cathode ray tube technology in this discovery. So as we see, this is the cathode ray tube, and cathode ray tube is made of course, the cathode, which is this, and the focus anode and accelerating anodes. Ito po yun. Tapos the deflection coils, which is this part, and then the phosphorescent screen. Number 1, nearly empty tube, and number 2 is an electric charge is passed through the tube, travels from cathode to anode. Number 3 is the charge is invisible, so to see where it traveled, the fluorescent screen is placed to the back of the tube here. And then where the beam meets, a dot will appear on the screen. You could also use a fluorescent gas and the whole tube will light up. And number 4 is this beam will always travel straight if not interfered with. Number 5, the deflection coils each have a specific charge. One is positive and of course the other one is negative. And the last one is Thomson showed, as in the diagram above, this one, that the charge would deflect away from the negative coil. He then started that this charge was just negative charge.
This is Ernest Rutherford. Ernest Rutherford was not convinced about the model of atom proposed by Thomson. He though set up his now famous gold foil experiment. This is Ernest Rutherford gold foil experiment. This is fluorescent screen, and this is the gold foil, and this is alpha particle beam and radiation sources. He fired alpha particles at a gold foil. 1. 2. He measured the reflection as the particle came out the other side. 3. Most of particles did not deflect at all. Every now and then a particle will deflect all the way back. 4. He said that they're the most positive center of the point. He called this center is the nucleus. This is Niels Bohr. Niels Bohr agreed with the planetary model of the atom, but also knew that had few flaws using the knowledge of energy and quantum physics, and was able to perfect Rutherford's model. He was able to answer why electrons did not collapse into nucleus. This is N shell. This is M shell. This is L shell. This is K shell. This is positively charged nucleus. Number 1, electrons orbit the nucleus in orbits that have set size and energy. Number 2, the lower the energy of the electron, the lower orbit. Number 3, this means that as electrons fill up the orbitals, they will fill the lower energy level first. Number 4, if the energy level is filled or at a capacity, a new energy level will begin. Number 5, radiation is when an electron moves from one level to another. This is Erwin Schrödinger, was a laboratory physicist who used his brain uncertain principle to come with the atomic model that
that we still use today.
This is the model. This is the electron. This is electron cloud. This is electron. This is proton. This is average of this average distance of electron from proton.
Next is history of elements. The periodic table is arrangement of the chemical elements which is organized on the basis of their atomic numbers, electron configuration, and recurring chemical properties. Elements are presented in order of increasing atomic number. The standard form of the table consists of a grid with rows called period and column called groups. And the history of the periodic table reflects over the 2 centuries of growth in the understanding of chemical properties with major contribution made by Antoine Laurent de Lavoisier, Johann Wolfgang Dobereiner, John Newlands, Julius Loder Mayer, Dmitri Mendeleev, and Glenn T. Simmons.